Hello, friends, and welcome to JRush Episode 5. JRush is a series of free web conferences on innovative real world solutions, tools, and methodologies in the world of JVM. And today's episode is all about enhancing the security of Java and Spring apps in view of modern cybersecurity challenges and realities. The top experts from Broadcom, Sonar, and Bellsoft will explore three pressing topics: passwordless authentication, cybersecurity threats posed by AI, and critical vulnerability management. We have a chat, so say hello, say where you're from, where you're joining us, and of course, post any questions or comments that you have for our speakers. And at the end, we will have a Q&A session where I will ask these questions. So, I will be your host today. My name is Catherine Edelweiss. I am a developer advocate at Bellsoft. Bellsoft provides Liberica GTK, recommended by Spring, Graal VM Community Edition based Liberica Native Image Kit, and Alpaquita Linux, which is a minimalistic Linux distro for containers and VMs with enhanced security. So, if you are here today, which means you care about the security of your apps, you might be interested in containers for Java apps based on Liberica GTK Lite and Alpaquita Linux. They are open source, small, fast, and continuously updated in accordance with zero CVE principle. Right, so without further ado, let our webinar begin. I'm joined here by our first speaker, Daniel Garnier-Muaru. Daniel is a software engineer for the Spring team at Broadcom. He contributes to Spring security, teaches computer science, and gives regular talks at international conferences on Java and Spring development. Welcome, Daniel.
Hi, nice to be here. Hello, everyone.
Hi, how are you today?
I'm good. It's a bit hot here in Paris, but
Oh,
I'm good.
what's the weather like?
Oh, it's gorgeous, very sunny, but it's about 30 degrees, and I think it's going to keep going up over the week. So you can't see it on webcam, but I'm wearing shorts.
Ooh, well, me too, actually. So that's the beauty of online conferences and Zoom talks.
Exactly.
Right. All right, friends. Daniel will tell us how to enable passwordless logins with Passkeys in Spring apps. Daniel, the stage is yours.
Thank you, Kat. All right, let's see if we can share my screen. Cool, this seems to be working. Hi, everyone. So let's talk about passwords. Um, so Chandra says, I don't need an intro, but I'm going to give you an intro anyway. Hi, I'm Daniel. I work in the Spring team. I do some commercial stuff, packaged products that we sell to our customers, but also security related stuff. So Spring security, of course. These days, Spring AI, the security bits, because the AI also needs to be secure. Here are my socials. So you can find me on Blue Sky. You can find me on the internet, on GitHub. And, the reason I do these conferences is to share some of the stuff we do with you, but also hear from you, like get feedback of your real use cases. So after this, don't hesitate, shoot me an email, shoot me a message, and I'll be happy to engage. So the topic of this talk is passwords, or rather lack of passwords. The year is 2025. You probably do not need to be convinced that passwords are terrible. They're not terrible in themselves, but they have a lot of drawbacks. They get leaked, they get reused across websites. Sometimes they're too simple. So if you don't have a good password hygiene with a password manager, it's probably going to be a problem at some point. And for the past 5, 7 years, we've had a new technology emerge on the web to log in without password, and it's called Passkeys. The term was coined by our friends at Apple, I think in 2018, 2019, something like that. And funnily enough, when I go to conferences and I talk about Passkeys, I always ask the audience, do you know what Passkeys are? And for the few people who know, do you actually use passkeys? And usually in a room, I get like 5, 10 people who actually use passkeys. And we're developers, right? So we like cool technology. And even within the developer crowd, it's not that well, understood or well used. So I want to show you how it works before we get into the details of how it works internally and how you can add it to your Spring app. So here is my GitHub on here, or GitHub not logged in. And on the right, you can see what my phone shows, and it's my computer with some devices on it. And so if I want to try and sign into GitHub, I could go and type, my Git email address and then some sort of password. But then if I do this, I need second factor. So maybe get a code, maybe get an authenticator or something. Or I can go and click on this continue with passkey button that GitHub has. And if I do this, a little pop-up comes up here. It's a bit small. You can't really read it, but it says you will be signed into github.com using blah, 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 your username. And so to do this, I use my fingerprint. I put it on the Mac's fingerprint reader. And this unlocks something on my Mac that does a little bit of cryptography for me and then proves my identity to GitHub. And so it does two things. It's two factors already because the credentials are on this device on the Mac. So it's something I have. And also it's using biometrics. So something I am. The reason this works at all is because I have pre-registered my Mac to work with GitHub to log in. So if I go in here into settings, into password and authentication, then I have a list of devices I have registered to use passkeys. So the Mac is one way. I can use physical devices as well. So in here, if I sign in again, continue with passkey, you can see blinking things here. This is a USB drive. It's a YubiKey, and it contains cryptographic credentials for logging in with passkeys. So I need to provide some PIN, something I know, and then this device, something I have, and I do two-factor all-in-one with passkeys. I can also do it with a password manager, and my favorite way of doing that is using a phone. So you can use your phone to hold your private keys, and the phone will do all the cryptography that's necessary and only give a little bit of information for you to your computer so that you can log in. So in here, I select other signing options, and then it gives me a QR code. I can now use the phone to point at that QR code, click sign in with a passkey. The phone and the computer are going to start talking together. And so on the phone here, I select which passkey I want to use. I click continue, and you can see it blinks and says use your face to unlock the phone. So sure, I click Face ID. It uses my biometrics, signs what needs to be signed. And so using my phone, I am now logged into my computer with passkeys. So this is passkeys. This is how, that's the user experience, if you will. Before we go into the actual implementation and what we need to do this, I want to clear out a few terms. So a passkey is a crypto credential that's tied to my account for a specific app. So it's a private key, basically. And that private key only works on github.com if I use that. And if I want to have a passkey for Google, even on the same phone, I will have a different private key. So I never reuse them, and it's resistant to phishing. The phone or the YubiKey or the Mac or the password manager is called an authenticator. This is the thing that stores your passkeys and does the cryptography to prove it's actually you. Sometimes you will hear passkeys referred to as FIDO keys or FIDO2 keys. That comes from the FIDO Alliance, the Fast Identity Online. All the big names are here: Apple, Google, Microsoft, but also banks, Chase and American Express and Netflix and so on. And they publish protocols for doing this kind of cryptography. So they produce CTAP, which is for doing the phone or the YubiKey, so the more of the hardware part or the crypto signature part. And then they produce WebAuthn. And WebAuthn is the protocol that you care about as a developer. It's the thing that you're going to use. It's a spec that gives you JavaScript APIs you can use in your browser. So let's check it out. WebAuthn level 3. It's a typical W3C spec. So something very nice and readable that has it has code examples somewhere, right? So it has code examples. If you scroll, you'll probably have, diagrams and types of diagrams and 300 pages of spec. So as a developer, you don't want to have to go through all of this, right? You want something simple. And this is why we implement it for you in Spring Security so that you can use it. So how does it work under the hood? How does that WebAuthn thing allow me to have users log in? So passkeys work with cryptography, as I mentioned earlier. When I register my phone on GitHub to log in there, the authenticator, the phone, generates a private key, stores it privately on the phone, and then shares the public key with GitHub. And later on, I can reuse that to log in. So the first phase is called a registration phase. It's when I add an authenticator to an app. So I'm going to generate the private key. It's going to be tied to github.com to that one domain. And I send the public key to GitHub. GitHub keeps the public key. And then the next time I want to log in using a passkey, I'm going to use the private key to sign something. And then GitHub is going to use the public key to verify the signature. And so since this cryptography ensures that only I, with that private key, was able to generate the signature. And so in practice, if you want to see how the interactions work, we can look at registration. So two things, right? Registration and authentication. Let's look at registration. You have a, a bunch of things that happen. If you read the spec, you get these diagrams and they're a bit complicated. And so instead, I'm gonna do a simplified diagram where you can see the four entities that are involved in the passkey flows. So of course, there's you, the human, right, who's trying to log in. You're using a browser and you're trying to access a server, so github.com in that example. And to prove your identity or to register a passkey, you're going to use an authenticator, so your phone, your Mac, your Android device, your Windows Hello, your YubiKey, whatever. And so at some point, you're going to say register. And here, the server will generate a random challenge. This time, every time I do a passkey action, I will need to provide a different signature. So no one can steal a signature I've done in the past with my authenticator and replay it. So the server generates a challenge, sends that to the browser, and then the browser calls the credentials API. And it says credentials create. I want to create a passkey for this website. This triggers my authenticator. So the authenticator wakes up and it says, oh, it seems you want to create a passkey. As a human, you need to interact with your authenticator for this to do anything. We want to avoid, websites trying to attack your passkeys and leak your private keys or, do denial of service on your authenticator. So you need to be present clicking on the thing. Maybe you do biometrics, maybe you do a pin, maybe you just do a click. But as a human, you say, yes, I want to create a passkey. So then your authenticator says, okay, and it creates a key pair. So private key, public key, and it signs the challenge. So it stores the private key securely in a secure, memory space on the device, signs the challenge, and then the return value of the credentials create function is basically this. It's the public key and the signature of the challenge that was sent by the server. So then your browser takes that data and then sends it back to the server, and the server verifies the signature, and then it stores the public key so you can log in later on using your private key. So it's a lot of things, but fortunately, as an implementer, as a developer, you only need to care about what is on the left side of this line here. So you don't need to care about the authenticator because you're not making an iPhone or an Android device. And you don't need to care about the user because you're not writing code to represent the user. The user is doing the action. So you care about the server and the browser. So this is JRush. Obviously, the server is going to be done in Java, in that case in Spring Security. The browser, though, the APIs of the browser, you need to use JavaScript for that. So in our case, everything on the server will be handled by Spring Security and the library it uses, and then everything in the browser is going to be JavaScript. We in Spring are not in the business of providing JavaScript libraries, but we give you a working example so that you can take that and then modify to create your own experiences if you need. You already have something out of the box that works. So that's for registration. Authentication is basically exactly the same as registration, but instead of calling credentials create, you get an existing credential. Instead of creating a private key, you load the existing private key, and then you just send the sign challenge to the server. And the server doesn't need to store anything. It just needs to verify that the signature that you sent matches the challenge and the public key that it knows for you. Okay, Before we get into the actual code, one thing that I want to reiterate that, sometimes people get a bit scared about this. Passkeys, they're not biometric. Passkeys, they're a private key. They're cryptographic credentials with some metadata. So when I register my phone with my face on GitHub.com, it's only the public key that is sent. It has nothing to do with my face. Those private keys, they're stored somewhere. So maybe in my password manager, maybe on my phone, my laptop, whatever. To unlock that device, I may use biometrics. So the biometrics do happen, but they only get between me and my device. They're never shared with the party, the website I'm trying to log into. And sometimes these keys, they're synced to the cloud. So if you're using a password manager, of course, they're in the cloud. If you're using, Android, they will be in your Google account. If you're using iOS, there will be in your iCloud keychain, whatever. But it's not a requirement. All right. Whew, that's a lot of theory. But what we really want to see is some code. So let's do that. I have a Spring application that is running here. It's a very simple Spring application. When I go and log in, I go to localhost 8080, and then I have, the default username, password, login, right? So now if I want to add passkeys to Spring Security, I go to Josh's secret favorite place on the internet, which is docs.spring.io, and then I'm going to go to spring-security to go to the project. And in the docs in here, you can look for passkeys. And in Passkeys here, you have all the docs that show you all the code you need to type and all the customizations you can make for your passkey login if you need to. But most importantly, it shows you in the beginning that you need to add a dependency. We don't roll our own crypto for verifying the signature that a user sends. The spec tells you there's 27 steps. So we don't re-implement that. We reuse what the community provides. So WebAuthn4j is a great library for passkeys if you're doing, just the WebAuthn implementation part. So let's put that in our build. Implementation. There we go. I'm going to reload this, restart my application because I want my application to pick up that new dependency. And then I'm going to make sure that my app gets rebuilt every time I make a change. So now I have the dependency, and then I need to do a little bit of configuration. So I'm going to go to the security configuration here. In my security configuration, I said, my users can log in with their username and password with form login. Now I say they can log in with WebAuthn. And you need to configure a few things. So first, you need to configure the RP name, the name of your application to be displayed to users. So Spring Passkeys Demo. Then you need to configure the RP ID. That's the domain on which your app runs. So on the earlier example, this was github.com. This allows us to avoid any kind of phishing so that passkeys are linked to one domain. And then the last thing is the origins, because maybe you have subdomains that are allowed to use the passkeys. Maybe you have different ports and so on. And that's it. With that configuration, when my app restarts and I go to, and I log out here, there we go, restart, I have a new button here that says login with passkey. And if I click on it, it brings up the passkeys dialog. So I could go and register a passkey, but there's one little problem with the current implementation that I have here. This is all in memory. Scream. So we don't want this to be in memory, right? We want to store the public keys of our users, not lose them every time the app restarts. So there's two tables you need to add to your database or to your, data store. We assume you already have users because your users are logging in and they have some sort of identifier, maybe a username, maybe an ID. You need to add two new tables, the user credential record here, which contains the public key of the passkey. This is the actual data of the passkey. And then a public key credential user entity that links your users to your passkeys. And that's it. Fortunately, Spring Security provides JDBC implementations for this because it's not real unless it goes in a database somewhere. So as a user, you can go to the docs, or you can type that yourself. So user credential repository, let's call it passkey repo, and then return new JDBC user credential repository, takes JDBC operations. And then the second table is public key credential user entity repository, user to passkey repo, JDBC operations, return new JDBC credential, and there we go. So with these two things, now my data is stored in the database. Of course, I need to provide a schema, and if you want to learn more about the schema, you can go to the implementation of the JDBC repositories here, and you'll see at the top it tells you, oh, you need to implement what is in this file, this SQL schema here. So copy that. I open the file, and here it is. So you can go and you can go steal that. That's mine. That's not the one I want. This one here, org. There we go. So you can go and look at the actual table that you need to do to add to your database. And so with this, now we have everything we need to do Passkeys. So the app is reloaded. I'm going to log in with a username and password because my app doesn't know about Passkeys yet. I go to the default UI to register a passkey. So let's call it Touch ID, register. Now my Mac says, do you want to register a passkey? Yes, I'm going to click this and register my passkey with my fingerprint. And so now if I log out, and I click login with a passkey, I can go and then touch my fingerprint reader, and then I get logged in to my application without using a username and password. So that's the default out-of-the-box use case. You get all the Java, and then you get a page that works. But probably if you're offering passkeys to your users, you don't want this like default page, right? You want some custom login to be implemented. So let's try and do that. I have prepared a custom login page with a button here that doesn't do passkeys yet. So first, the most important thing is you want, a custom experience. So let's go to that custom login file, and we're going to add some flair, some style to our passkeys login page. So this is called sign in passkey. We're going to say the font size is to rem. Maybe we put some padding to rem as well. Sure. We need to set some font, so probably Comic Sans, right? And then maybe a background, because the background is snazzy. Linear gradient to top right. And then what do we do? Tomato to some sort of blue, dark blue. Okay, so this probably needs a little bit of white to be able to read what's on here. Color white. There we go. Beautiful. And now, voila. This. You can tell I'm a real CSS expert here. Okay, so now I need to make it do something. So to make it do something, I need the JavaScript. And for this, instead of reinventing the wheel, you go to the Spring Security project on GitHub, and then you look for the code that does WebAuthn in JavaScript. So WebAuthn core here, this is licensed under Apache 2, so you can steal it and then put it in your page. The easiest way to do it is to go to the default page that we provide. And in here, I go to the console, and then I go steal the code in here. It's actually quite a lot of code. We do a lot of things in JavaScript for you. So I steal all of this. Cool. I put it in my JavaScript. Okay. And it has an authenticate function. So I'm going to call this authenticate function here. Await, authenticate. I need to pass some headers, the context path. So, if my app is under foobar API, I put it here. For our case, it's just the root, and then no conditional mediation, which is advanced Passkey stuff. So this gives us a redirect URL here. So once the user has been able to authenticate, we then redirect the user Windows location.href equals the redirect URL. And the last bit is the headers you need to pass in here. Here, you need to pass CSRF headers, because you're going to log the user in. So please, I see you doing this. I know you do this. I go to conferences. I listen to you. You do CSRF configure disable. And when you do this, I say no, die, and I die a little bit inside. Do not disable CSRF. Pass the correct headers. You have all the tools to do CSRF. So in here, you will pass the CSRF token. CSRF get header name. So this magic square brackets is timely way of injecting data into JavaScript. Get token. Okay. And so with this, if the demo gods are with me, I can go back to custom login here, right? I can click sign in with a passkey. The dialog comes up and I can now use my finger and log in into my app using a custom, beautiful login page. Okay, that was a lot. So a few takeaways from here. As you can see, it's complicated. The, the Java part we wrap for you, we give you the defaults and it's kind of fine. The JavaScript, a little bit more complicated. If it's possible, I would recommend not implementing Passkeys yourself because your Keycloak, your Azure Entra ID, your Okta, they all support Passkeys already. So you rely on them to do single sign-on. They handle user Passkeys and so on. And you as an implementer, you just do single sign-on with OpenID Connect. Sometimes you can't do that. So in that case, if you're doing implementation on your side, use a library. It's still going to be complicated, but it's going to be slightly easier. With Spring, you have Spring security support. Please help us make it better, contribute. You can go to GitHub to the project. You can propose code, but also you can go into the issues and like look issues that look like what you need or what you want, and you can upvote them so we can know what you care the most about. And then a great resource, developers.ubico.com is probably the most comprehensive resource if you want to do more advanced Passkey stuff. They tell you all the APIs that are available, all the trade-offs, and so on. Whew, I think I am slightly over time. I am sorry about this, but you can find the repository for this presentation on GitHub. And again, please reach out to me on socials, internet, and so on. I would love to hear from you.
Wow. Daniel, thank you so much. That was super interesting. I mean, friends, I don't know about you, but I'm that
I
kind of
breathed in.
person who hits reset password even without trying to remember it. So I guess passkeys are a way to go. And we already have some questions from the audience. And the first one is Pasha. Should I enable CSRF for pure REST APIs too?
It's an excellent question. So CSRF, if you're doing machine-to-machine communication, no, you don't need to do CSRF because it's for cross-site. So there's an idea that a user goes to a site and then gets tricked into doing something that they don't know they're doing. So if it's just a microservice calling another microservice, you don't need CSRF. If it's a website, like a single page app, then yes, you need to do CSRF. And if you go to the Spring Security docs and you look for CSRF, we have long guides that explain all the way you can do CSRF, even for single page apps, which have different variants and different little details. But mostly the answer is yes, you should.
Great, thank you. Right. To what? Sorry, the question from Steven. To what extent are passkeys more secure than two-factor authentication?
So that's a great question. Passkeys are not inherently more secure than two-factor authentication. The idea is they tend to pack these two things together. It's not necessarily true. You can do passkeys with a single factor. That can happen. But one, they are resistant to phishing. So even with 2FA, you can get phished. With passkeys, your computer will not do will not sign a challenge for a website that is wrong, that has like one character that is fishy in the URL that is different from the real thing. So in that case, that's an advantage. And the second is, I mean, the user experience is great, right? I can go in, I take my phone, I say log in into GitHub, I put my face and boom, I'm logged in, rather than having to like, oh, I have my two-factor here, so I need to have some recovery codes stored somewhere safely at the bank, and then I need to not reuse passwords. So it's a little bit of a less stuff to do. When you have passkeys, though, you don't want to lose the device that has your passkeys because then you're locked out. So you will tend to add multiple passkeys for a given website. So you've seen on GitHub, I have like 5 different passkeys. So trade-offs, but mostly what we hope is that the experience is better than using passwords than a second factor.
Right. Okay. Rihara, wonderful explanation. Loved it. Well, thank you.
Thank you.
The question is, are there any workarounds for the JavaScript Control C, Control V?
So the thing is, if you wanna do it right, you probably should kind of start learning about the APIs. And so the Ubico website is a great place. The Spring Security documentation has some information as well, uh, and then there are some libraries, but they're not they're not made by us. So I think GitHub has their own Passkeys JavaScript library. I am not sure how well it will, adapt to the format that Spring Security accepts on the server. So it's
Mhm.
we're not that much into the JavaScript business. We did it because we have to, but there will be some work on your part here. That's for sure.
Okay, great. Well, Pasha has another question. He wants to ask it in person. Hello, Pasha.
Oh, you're a mute, friend.
Yeah.
Hey everyone, we'll see each other a little bit later, but I wanna hijack Daniel just for a minute. Daniel, I like the idea of passkeys. They're beautiful. Like I don't need to type my passwords and so on. So how do I move my passkey from iPhone to Android phone?
So the question is, can you move your passkeys, move all your
Between authenticators, essentially.
right, exactly. So you don't do that. It's not possible. The idea is that the private key can never leave the authenticator except in blessed ways. So in the case of the iPhone, it's only compatible with the iPhone ecosystem. So if I've generated, or in the Apple ecosystem, so if I've generated a private key on my phone, it can sync to my iCloud keychain, and so I can use it on a Mac and another iPhone and so on. Same for Android. If you want to have passkeys across multiple types of devices, you can't move them. You have to recreate a new one. There is a hack around it. You can use a password manager because password managers integrate with the platforms as well. So, for example, on my phone, I can use a passkey that's stored in 1Password, which is the password manager I use. I can also use it on a computer. For example, my Linux computer doesn't have any passkey support, and so I use the password manager there, and it's synced on the cloud across all my devices. So I think if you're, a multi-ecosystem and you want to move things around, password manager is probably your best bet.
Yeah, I'm currently on Mac, and I usually work on my Linux. I also have an Android device. They all have slightly different format standards and so on. I use Bitwarden to store my passkeys. I'm not sure if it's safe though. Like, I mean, it's supposed to be, but who knows? I just had like you can share your second factor if it's OTP
Yes.
anywhere.
Yes.
With passkey, it's not that simple, and this is what I
And it's
don't
the whole
like.
idea, right? It's that these credentials are really hard to leak. And so we want them to be very tied to your device. When they started, it was mostly YubiKeys, so they stay in the cryptographic key that no one can extract the private key from, right?
Thank you so much. Thank you for the answer.
Right. Okay, Pasha, I'll
Yes,
hide
remove
you
me.
for some time. Right, Daniel, there's the last question from Daniel also. Would you use Vardin to skip the JavaScript part? That's a good question.
Ah, it's an excellent question. So I don't know if Vaadin has passkey support. I have not checked, but you will need to have JavaScript anyway because it's calling to the browser, and so it's kind of like storing, local storage in your browser or calling a browser API. If you're drawing on a canvas, for example, you need to be calling some JavaScript, but you do need a little bit of JavaScript. And so I'm looking on the Vaadin website, and they're saying for passkeys they have this execute.js, and so there's clearly a little bit of JavaScript in here. You can wrap it in Vaadin, but you will not escape the JavaScript hell.
Wow. Right. Well, thank you so much, Daniel. I mean, that was fabulous.
Pleasure.
Fantastic
Thank you
having
for all
you.
the questions. It's
Yeah.
been really nice.
Yeah. Friends, if you have any more questions for Daniel, you can just post them in the chat and we will pass them to Daniel later. All
All
right.
right. Cheers
Okay.
and enjoy the rest
Oh,
of the session.
thank you. Thank you so much. Bye-bye. Bye. All right, friends, and here I am, joined by our second speaker, Margarita Nedzelska. Margarita is a staff software engineer at Sonar Source and a Google developer expert for Kotlin. She contributes to developer tooling and static analysis in the JVM ecosystem. Welcome, Margarita. Thank you for joining us.
Sure.
You are muted.
Um,
Yeah, now can hear you.
Do you hear me now?
Yes, yes.
Okay, yeah.
All
Thanks
right.
for the introduction and for inviting me. So it's really pleasure being here. And I have to correct you. It's recently Google Developer Experts upset the category of Kotlin, so I'm not a Google Developer Expert in Kotlin anymore because
Okay.
such category doesn't
Well,
exist.
X, then X.
So yeah,
Yeah.
I am
Right.
alumni. Yeah,
So how are you today?
yeah, fine. Was a busy day at work, and it's a
Right.
nice wrap up, I think, having a conversation with you.
Yeah. Well, friends, I remember that Q&A session is at the end, but I have so many questions for Margarita that I will use the privilege of being a host and I will have a little chat with her. So call as you may, right now. And we are going to discuss a very, very interesting, exciting topic very relevant to today is AI, cybersecurity threats. Classic and novel cybersecurity threats, such as AI prompt injection, and how we can protect ourselves from them. So, Rita, are you ready?
Yeah, I think that's
Yeah.
time to start.
Yeah, great. So I have a bunch of questions, and friends, if you have any questions for Margarita, please post them in the chat, and I'll ask them too. All right. And here it is to my first question. Um, Margarita, please tell us a little bit more about Sonar Source. What does the company do?
Yeah, I hope that maybe I'm doing my job right if everybody in this room knows what Sonar does, but if you don't know, so we're a company who is building static code analysis tools to detect code quality and code security issues. And in the past, I think, year, we did a lot of new stuff. And I think one of the recent releases introduced software composition analysis, so security composition analysis. So it's like now we can only also look in your dependencies. So it's like it was a huge step, huge milestone for us, and I hope people will enjoy it. And in general, our tooling is trying to make the world better, the software better. So we try to find your bugs, your code smells, your security vulnerabilities, hotspots. So they don't go to production, but you fix them and you're pretty safe. And we have a bunch of products like there is SonarQube in cloud. There is SonarQube on-prem for those who don't or for some reason cannot go on cloud. And there is also IDE extension for different IDEs that you can use standalone inside the IDE, or you can also connect to your server, whether it's cloud or on-prem server. And so you can have a better user experience by syncing the issues between IDE and your like server, so you can fix the issues before they ever met, before you ever committed them or ever pushed them. So it's even making static analysis even shifting left and making it closer to developers. And I'm working on these analyzers, and I've worked on a bunch of different languages, mostly on JVM ecosystem. But recently, I was very attracted and moved more to the security part. So probably this is why you invited me to talk more about security.
Oh, yeah. Well, security is pretty cool and really interesting sphere. And friends, we are going to discuss static analysis right now, what it is and how it can help you. But you can actually already go ahead and get the plugin for SonarCube in the IDE in IntelliJ IDEA. I know it's there. So you can get it and start while looking at your code, start pondering what went wrong at what stage. Yeah. So, Marita, can you tell us a little bit more about static analysis? What exactly does it do?
It's actually like, in simple words, we are trying to analyze your source code and detect potential issues. If you want to dig a little bit more, how I usually like start talking about static analysis at my talk, I like think of like in very simple words, like you write some source code. Source code is our input. Then we take the source code, transform it into abstract syntax tree, like the first step that usually compilers do, and then we use this abstract syntax tree to run some visitors on this tree and find some like patterns, some like something inside this tree that trigger an issue. Like for example, on this tree, we can see that some string is duplicated multiple times, or some API that is forbidden is used, or like actually almost like many different things. And this is like the simplest level is to go through the syntax tree. Then if we need like more information, for example, we need information for types, for symbols, we can go further and we can explore semantic model. This makes analysis much more advanced, but this of course comes with a trade-off that it will have more it needs more like dependencies, and it needs more like part of the compilation of this, or like we don't completely compile stuff, but we need to resolve something there. So this is like more advanced step, but this comes at the cost of performance and of like somehow providing the dependencies. And then like there is the next level, which is like actually data flow, where we not only have types, but we also try to like build control flow graph and understand like how the data flows from one place into another, and make even more advanced rules there. And then like in simple words, we are trying to execute your program without actually executing it. So we try to assume how it's going to be executed, which path it should go, and validate. And based on these three different stages, there are different rules. Like, for example, if it's just some code style rule, how your functions should be named or class should be named, it's just syntax. If, for example, for some reason we need to detect types, that types are resolved correctly, or something where we need types or some APIs, there we need semantic models. And like maybe the most interesting and the most advanced bugs were actually like input validation and sanitization. This is data flow. So we need to go through one place to another and understand how the program flow works, how data comes from one place to another, and like on this way we can detect even more advanced issues. So I hope it's like clear in simple words.
So, do I understand correctly that with the static analysis, we can find both security and quality issues with the code?
Yes, we can find different both security and both code quality issues, but of course we cannot find everything, because like there is a halting problem that exists, that not all the we cannot like prove that the program terminates, so we cannot actually always find everything that we want to find. And this is one of the problem, one of the things that I'm thinking about, and we're all thinking about sometimes. If the SonarCube or any other tool doesn't find anything in your code, or especially like security vulnerabilities, it gives you sense that you're safe. But
That was actually, one of my next questions.
yeah,
The illusion of being safe, right? In a
yeah,
way.
but this mostly an illusion of being safe, because that's Like we don't know what we don't know. Like if we just don't detect some kind of vulnerability, that doesn't mean that you don't have it. It just we never tested your code against this vulnerability. And this is like, yes, when we are using such tools, we should all understand this trade-off. That of course we are trying to do our best, we are improving, but things happen and we cannot protect you from everything. So of course there should be some common sense. And
Um,
of course there is some things like false positives and false negatives. So
that was also one of my
yeah.
questions. Right.
Yeah.
Okay. Yeah, about the false positives. So, what do you do actually if the analysis identifies false positives? Ignore it somehow, uh, or it just the code can't go through the CI/CD pipeline if there is this issue detected. So, what do
Uh,
you-
yep. It depends like on which stage it is and what do you mean by this false positive and false negatives? Because like, let's focus on false positives. Because for some reason, people are more annoyed by false positives than false negatives. Because like when something is reported which is not correct, customers and users are usually annoyed. When we report nothing, uh, like people are usually happy even if there is actual issue. So we are joking sometimes that the best rule is a rule that does nothing because it has zero level of false positives. But yeah, jokes aside, it depends on the type of these false positives. For example, sometimes there are issues that are false positives because it's FP in your case. Like, for example, we don't know like more information, or we cannot detect it, or it's just like because something is configured somewhere outside of your code and we cannot know this. This is your false positive, which is like not the general rule. So we recommend just to mark it as an FP or accept the issue, however, but you cannot fix it because there is nothing to fix, but there is also nothing to fix on our side. So this is one of the state where you feel like accept the issue on the tool level. There are other types of issues, which is like probably bug or some limitation of the engine that we use. And usually we receive such reports either we find them by ourselves or by our colleagues. Sometimes we see it on our community forum or from our paid customers. And these issues, we look in the code, and if it's possible, we fix it. If it's some limitation, we like publicly state it somewhere in our community forum that sorry, we understand this limitation, but this is some corner case, so we can't do anything with this. But yeah, in general, we try to be very responsive and try to fix and adjust the rule. Sometimes it it happens, especially like for such an old analyzer as Sonar Java, which is one of the oldest. That there are so many there are so many false positives, some corner cases that even so simple rule that is like 3 lines of code can become a very complex one because it has like 30 different kinds of corner cases where it should not work, and we should all this keep all this in mind to like satisfy users and to not report stupid issues. So if we see things like this, sometimes we think maybe things like this worth some adding some parameter and parameterize the rule so people can configure this. And sometimes this happens that we add a parameter to the rule so people can configure it and fine tune it for their needs. So there are different strategies how to deal with FPs. Yeah.
So you can configure the rule, you can adjust it, or you can create even your own rule, the enterprise specific one, right?
Yeah, it depends on the analyzer, on the rule. Not all the analyzers allow it. Not every rule has parameters, but sometimes, for example, instead of trying to guess every single type of methods that contain assertions, we sometimes can provide you regex where you write which library you're using or what are the patterns of your assertions. So we don't try to guess, but we are using what you use. The same, I think, is also for secret detection and password detection. So we can also use your patterns instead of trying to write some heuristics and trying to guess.
Right. Okay. So the last question about static analysis in general. So, is it does static analysis make code review by humans unnecessary?
Oh, I love this question. That's like especially today with the rising of like AI, LLMs, and all this GitHub Copilot reviews. Uh, Everybody's dream that, of course, that we make code reviews by human unnecessary, which is probably the state that we all want to achieve at one day, but I think we'll unlikely achieve it because everybody makes mistakes, machine makes mistakes, and the more a pair of eyes look at your code, the better. But like I even had we had an idea with my colleague to give a talk about how to do code reviews, which is very to say hot topic, because our idea was that we don't really need code reviews at all because we need to shift the way how we actually work.
Mhm.
At to my point of view, it's not about code reviews. It's more about how you develop things that currently we still need to involve humans, and we need to involve like more than one. If you do like pair programming, this is still okay. Like if you two people like coded the same thing together, you don't need code review because you kind of already reviewed it together. And as I told you, static analysis has limitations. We cannot eliminate human eye. We cannot eliminate like the bugs that static analysis cannot find. Like even things like now the reference check, it's still hard to like find 100% of cases. And there is also another thing that probably all the tools we cannot achieve it, we cannot find it. It's the relevance and the like. What we actually code it, is it correct in terms of what we wanted to achieve? Because the code might be clean, might not have any code smells or bugs, but it potentially is not doing what it's supposed to do, or it has some like bigger business logic mistake. And this one can only be detected by human, not by machine. Like maybe in the future with AI it will be better, but at the moment I think having a second pair of eye, whether it's a reviewer or a second programmer in pair programming or whoever, but it's still necessary.
Well, speaking of AI, so as we enter the age of AI, many things have changed in our life, and for sure, the cybersecurity landscape has changed as well. And does AI do more help or harm in terms of cybersecurity?
Oh, that's a good question. It's hard to say whether it's what's more good or bad, because of course a lot of tools and both like and even at Sonar we are trying to empower like have AI to help us find some issues, and for some issues it makes sense to actually train the model to detect them. So of course AI is used to detect issues as well. However, having AI powered application also introduces another whole story of like vulnerabilities, of potential security breaches and so on. And it's just like another vector of attack. Like we already had a lot of, and now we just need to look at even more. There is a global organization of us that publishes like 10 top vulnerabilities,
Yeah.
and there is like general WASP top 10, there is mobile WASP top 10, and now there is LLM WASP top 10. So
Wow.
there is 10. I don't want to talk about all of them because there are a lot and a lot of different things, but I think one of the pain points today is prompt injection.
Mm-hmm.
And
So,
I think it's,
yeah. Mm-hmm.
if I'm not mistaken, it's top one. So the thing that was not possible before, we had a lot of AI powered application, now is possible.
Mm-hmm.
And now we should also protect ourselves from prompt injection. And
Right.
the
So
fun
let's talk more
part.
about prompt injections. It's a really exciting topic. So how are they different from SQL injections, and what is it actually all about?
Yeah, that's in terms of like of technology, like it's pretty similar to SQL injection. So there is user input that goes to some sink and like to some place where it is executed. And if you don't escape, like you can execute this user input and can potentially produce harm to your database and actually to your application and your potentially company and whatever. Prompt injection is pretty similar, instead that the sink is not actually your database, but this is your API for LLMs, like the place when you like call, when you call LangChain for J or whatever, how you integrate, depend on how you integrate with LLMs. But this place will be sort of a sink. And indeed, if you do know nothing on the way to validate this input, you're vulnerable to prompt injection. But if you look at this, not from the technical point of view, but from the like nature point of view, it's absolutely different from the SQL injection. First of all, we can forget it's very important to find SQL injection paths, but once you know them, it's easy to protect from them. You escape, you just don't execute this user input. But from LLM's point of view, it's hard to understand how to protect yourself. Because of course there are some validators and all the libraries, they add sanitizers and validations to the prompt from user, but we cannot guarantee, because in terms like what LLM is by nature, we try to emulate like sort of a human, like what is AI? Actually, we are trying to emulate human behavior to some extent. And it means like it's not the database that executes SQL query. It's LLM where we cannot predict how it can behave. And here, the prompt injection by nature is more like social engineering. We try to convince LLM like that I'm admin, forget about all past instructions and whatever. And yes, we can protect ourselves from some common phrases, but we don't know what people will come up with tomorrow. And if there is something that we don't protect ourselves, then it will go through. And the fun part, when I was preparing for this interview and Googling something, what is the best way how to protect, and I was looking at some sanitizers, what to use. I found a perfect phrase. I forgot who said this, but the best way to protect yourself from prompt injection is not to use LLM. Because honestly, there is no way to protect yourself completely. Like you can only like try to protect from 90% of common possible prompt injections, but still it's not that easy. And another fun part, we are talking about the input, so it's like text field. When somebody is typing something, you're executing it. But the same can happen if you upload a picture or upload some document where LLM tries to parse it, and inside this, there is some command. So this type of injection is not called, it's called indirect prompt injection, and so on. And people can find so many different ways how to like break in. And yes, once we know this, we can try to protect. But of course, there is a bunch of things that we can use to protect ourselves. First of all, like one of the best things that people suggest to do and is not give LLMs a lot of rights. Like if it cannot drop your database, even if the person asks, like or some and if you like take this input, you can do nothing because it doesn't like have access. The same way, like the way to protect the data is to introduce levels of like say authorization, so you cannot do, so you don't have LLMs too many, don't give too many privileges. So even if something goes wrong, it cannot do any harm. And yeah, this is like one way of what can go wrong. That somehow your LLM goes into your not LLM, your prompt goes into your program and like produces some harm. Another possible thing could be that people use prompt injection to get the sensitive data from other users or from other customers or just about the company. So, and if LLM has access to this data, and even if it's just read, it still can be harmful. So, like, you can even try in some chatbots to ask, like, give me data about all your users, and you'll see that some of them can actually do it. So, the way to protect from this, besides validating the input, it's also important to validate the output to see that there is no like personal data, no BAI data that you can expose and whatever. So even if LLM like was stupid enough to give you something, you can still filter this out on the way out. So this is another thing that probably is crucial for prompt injection, that you to protect from prompt injection, to validate both input and output.
So,
And
are there any tools that can help us do that, or is it just about writing code ourselves manually for a little bit?
At the moment, I think it's hard to say because this subject just started. So I don't know if like huge players on the market are not yet there, but I do believe that maybe in few months, in a year, we'll have all common tools helping you detect like here. So cannot say more, but like let's wait what will happen. And but I think what's also important, since we have a WASP top 10 for LLMs, we also have like, of course, all the libraries to integrate with LLMs like LangChain, LangChain4j, and they try to like be like looking at all of this. And of course, so there are some built-in sanitizers, built-in mechanisms to do it. There are some tutorials how to work on this. So there is enough data on the web. So you have to search for it. You have to be responsible. About the tools, I feel like maybe I've seen some small maybe companies or some like other some tools that I never heard about that they claim we do it. For now, I don't see anything that I would probably recommend at the moment. But maybe like in a year we'll be at this and there, because I think we'll just need some time to develop things. As it's an important niche. It's definitely something that we need to write. But again, this is like, as we talked before, there is this sense of false security, like illusion of security. Here, this illusion will be even more, because as I told you, we cannot protect completely. And even if, for example, if we like in a year implement some mechanism to detect prompt injections, how we can say that you actually validated something? We can detect that you run some sanitizers, that you validated the input output, but it's not 100% of protection. It's just like some attempt. It just shows me that you're responsible, you want to be nice, and you want to protect yourself. But will it actually protect you or no? We'll only know like once you have some problem or no. So
Can we
it's
say that
time.
AI cybersecurity threats or prompt injection specifically is kind of like a social engineering, because AI is not human, but we try to deceive it like it was human because it tries to pretend to be human.
Yeah, that's exactly what I was talking. I think I even read an article about this subject from, I forgot from which company, but okay. But that's, yes, currently we are dealing with something that is like another kind of human. And indeed, here, social engineering works better. So, like trying to prompt injection, actually, this is a social engineering for LLMs. And this is why it's even harder to understand what can be harmful, what cannot. Like, yes, we can protect from the things like I'm admin or forget all previous prompts or like whatever, but we don't know how people can interact and what will trigger LLM. And because most of the like LLMs, they're not deterministic, we they can react differently on the same input, on the same phrase, depending on like
Mm-hmm.
different the context and other stuff. So this makes things even harder to detect.
Right. So AI brings some cybersecurity threats for sure, but can be used for good, can be used for enhancing security.
Yeah, we have. I was talking about this with our colleagues, like that. Usually, when there is a way that it's hard to write some algorithm to write something like very precise to detect, this is a way where we can use LLMs to generate the code to generate something that can help us or generate the prompt. But I'm a little bit afraid that eventually we'll end up that we will use AI to detect problems with AI, which is like there should be somebody else in the middle, or like
Yeah.
someone else in the middle who can orchestrate this part. But yes, indeed, I'm think that in the future we'll have even more and more AI integrated in like engines, and I've already like seen like lots of ads, lots of companies doing static analysis with AI. It's not. I don't think that we're talking about prompt injection, but even in general, static analysis seems like an interesting niche for AI usage. And like even at Sonar, of course, our engineers, we try to use AI as much as we can. It's not always capable of doing our job, but in some cases it really speed up a lot. And I think in the future we'll see even more of this.
Mm-hmm. Well, if we go back a little bit to more traditional cybersecurity threats, which classic, so to say, or traditional security threats are still relevant today?
That's all of them, I will say. As I like, even today, I was implementing some basic rule for a direct language, and I was like thinking how it's important. Like, I don't know, everybody knows that this algorithm is insecure. Like, we should use something else. But then we see the reach on our like SonarCube cloud, and we understand that no, it's still relevant. We still need this a lot. So yeah, what I was talking about. Yeah. Uh, so I think from starting from the most like painful SQL injections, like file traverser vulnerabilities, zip sleep, and to just simply using algorithm or not using like using some insecure old algorithm or using so like maybe accidentally hard coding your secret or your password. This all is still relevant, and it's even funnier and maybe even more scary that if your application is vulnerable for like just an ordinary vulnerability, like for example path traversal or zip sleep, and you also use LLMs, attacker can exploit your vulnerability, but and target LLM as well. Like, for example, one of the examples that made me like be scared and laugh at the same time was on the talk at Devox UK from Brian Vermeer, who was and Lisa Rice. It was about like, of course, about how to break applications with LLMs. And one of the examples was how they broke into the application because application was vulnerable to path traversal. So
Hmm.
they uploaded the file there and they put it into the right direction of terms of use. So like that's actually interesting. I think today, in order to protect LLMs from hallucinating and like to make them use exactly your context, to be more context aware of your like company, of your business, it's important to provide the right context. So you teach LLM with your like terms of use or with other documents about your company, and they know that LLM knows about this document and it's using it for helping like in the support. So what they did, they used this vulnerability to change this document and add in some special uh, note that if you break it here, like if you use this passphrase, you can do some admin stuff. And then LLM learned about this, and the person successfully used this for to get access to get some data and even change some data. And this is indeed scary that it has nothing to do with kind of classic prompt injection, but it was more about your application was vulnerable in general, so it's already not a good scenario. But together with LLM, it created a combo of producing even more harm. So yes, and that's important that we talk here about the classic vulnerabilities too, because having AI means that we need to put even more on general security as well, like more effort to be secure in general, plus effort to be secure with AI. Like having AI doesn't dismiss the general security.
Well, I guess then as a wrap up, we can say that, well, security has always mattered, right? And right now it's even more crucial, and we should always stay on guard,
Yeah.
and especially with the AI. So even more threats are coming all the time, coming at us, and there are ways to defend ourselves, I guess. Luckily, there are ways to defend ourselves, right?
Yeah.
Well, Marita, thank you so much for this talk. I mean, that was super exciting. And I actually have a lot of questions here from the audience. So please come back for the QA session. We won't let you go that easily. There are more questions that await you. Right. Thank you. Thank you so much.
Thank you.
Until in half an hour. See you again in half an hour.
See you.
Okay. All right, friends. And now, last but not least, our third speaker has joined us. Please give a warm welcome to Pasha Finkelstein. Or, I'm sorry, we have been discussing backstage
Yeah, that's
uh,
why I never pronounce my last name anymore.
surnames, and that's, yeah. So, Pasha. Yeah,
Yes,
Pasha, yeah.
I was
Uh,
here the whole time, as they say on the show named Game Changer. Highly recommend.
Yeah, actually, yeah. So Pasha has been here, like a guardian angel. So now I know I have known Pasha for quite a while now, and I don't cease to be amazed by how many things he does. He gives regular talks at conferences and jukes. He contributes to open source projects. He does YouTube videos. He does live streams. He writes code in Java and Kotlin. So, like a man of many talents. Welcome, Pasha.
Thank you so much.
Right. And today, Pasha will guide us to the backstage of CVE patching in open source projects and regular security updates. Pasha, I turn the floor over to you.
Yeah, thank you so much. Can I'm kind of sharing my screen, but I can't put it on the screen. Could you please? Yeah, here we go. So, contrary to all the speakers before me, both of them, they are amazing and they know all the stuff about their subject. I am kind of noob in security. So for me, it was more of a research. And today I will tell you how Beltsoft fixes what's actually broken. Because, they say if it ain't broken, don't fix it. Well, in our case, we should fix what's broken. A couple of words about me. I'm a developer advocate at Belsoft. You probably can see it somewhere in the handle. I have more than 10 years in JVM development. I would say it's probably closer to 15 years. And in IT, it's like 18, 19 years. I don't remember. I obviously use Spring in a lot of my projects. I know other technologies too and experimented with them a bit, quite a bit, I would say, especially in my Kotlin times. And I'm an average security enjoyer. It means I know my course, I know my XSS, I know what vulnerability is, but it doesn't mean I can give you, I don't know, qualified recommendation on how to improve security of your application. Usually I can't. Usually I'm really floating in it, really don't know this thing. But I'm trying to learn. And I have been thinking about security almost my whole career. It just was never my main job. So as I can't say you how you should do it, I can say you how we tackle security issues in our products in Bellsoft. We have like a security philosophy in Bellsoft. First of all, we are trying to be proactive, not reactive. It means that if we know that something can be a potential security issue, we are trying to fix it. We are trying to contribute the fix to upstream. It's not always accepted, but usually it is. And we know that CVEs, which are security vulnerabilities, by themselves are not failures, but those of them who are unresolved are. And this is why we have our own Alpakita Linux. I will tell you a couple of words about it a little bit later. We also support many versions, for example, of Liberica, many older versions. And we backport patches there, which is part of our security philosophy. And we are proud to have full stack control of the security, at least for Java stack. We have this Alpakita Linux and we can patch it. And we have Java, which runs on top of Alpakita Linux, and we can patch it too. And it means that if you use the whole stack, you are more secure than probably many other solutions. Why is it so? Because we know that shipping secure software is a process. It's not an event. It's not like we deploy a secure version of Java or a secure version of Alpakita in the wild, and that's all. No, it's a constant work of monitoring, controlling what's happening around, and fixing things. As I said, we have two products. One of them is Liberica JDK, and we support versions from 8 to 25, at least all the LTS versions. We support multiple CBU architectures, probably more than any other market. By the way, speaking about Java versions, we also have Java 6 and Java 7, just for commercial users, and I really hope that you don't need them. We have usual JDK, and we also have NIK, which stands for Native Image Kit. It's our own spin-off from GraalVM community, with additional perk of, for example, parallel GC included. Thing you don't have in your GraalVM community. Also, we support just usual version of Java and JavaFX versions of Java for JDK, for JRE, and for NIK2. It means that matrix of Javas we support is just insanely big. We are also a member of CNCF, which stands for Cloud Native Compute Foundation, Linux Foundation, JCP Executive Committee, and so on. The second product we have is called Alpakita Linux, which is a Linux, very minimal, based on Alpine. We fixed a lot of issues, some issues there, not a lot, some issues there in Muscle. We optimized the performance of Muscle. We also ship Alpakita with glibc. Theoretically, you can have glibc compatibility in vanilla Alpine, but you will have to install a huge package called glibc compat, which is still not glibc, and it's huge and it's slow. So you probably would prefer for your software to run on normal glibc, not on some compatibility layer. And we also have several languages in our repository for Alpakita Linux, Python, Java, and some others. And all of these products are open source. Why is it important? Why open source is important? Well, Linus Torvalds, creator of Linux, said once that given enough eyeballs, all bugs are shallow. And I like how beautiful and laconic and short it is. Actually, if you think about it, when enough people look at the code from different perspectives, they will spot the bugs, security issues, and so on, and they will be able to fix them. And actually, open source brings two sets of perks, and I split them in two categories. They're probably not imperfect, but still. First of all, community can bring us feature requests. They can do it for proprietary products too, if there is a way. But for open source, it's almost customary to have GitHub or GitLab or something like that, where you can write your feature request and probably have an author to answer it. They can bring bug reports, and if they are technical enough, they can even minimize bug report. They can try to find a piece of code that introduces bug and so on. Our users love, not only our users, in general, users love open source for freedom because there is no vendor lock-in, there is no nothing. If they want, they can change products like tomorrow, today. And also, technical users can potentially bring patches. It's a little bit trickier for Java. It's a little bit simpler for Linux probably, because for Java, you can't bring your patch to Rust. You have to bring it to Oracle and sign Oracle contributor agreement. But other than that, it is perfectly doable. And if you look at OpenJDK GitHub, you will see that there are quite a few external contributions. And also there are technological perks. For example, any company can do security audit of the source code, which is beautiful. I know that there are companies out there who decline to install any software that they can't verify, the source of which they can't verify. And also it gives a lot of opportunities to modify or harden software to your needs. It is even done with Java, for example. Alibaba changed Java quite a bit, but also there are built-in instruments to modify Java distribution. There is a JLink, and there are JRE, which is Java runtime environment, and etc. And if we are talking about Alpakita Linux, you can, for example, remove the package manager for it. It's your Linux, you can do whatever you want with it. I mean, it's a weird thing to do. You will lose your way to get updates without pulling the whole image, but you know what you're doing, right? And also, you can control what's happening in updates. It means you can eyeball the actual piece of code that has been changed from the previous update to the current update and decide if you need it, if you're interested in it, if you agree with it or not. Probably you will lose something, but you can also take this update, modify it slightly, apply to your source code and use it further. And open source really enables faster zero-day mitigation, because in open source, a lot of people can watch at source code, they can patch source code, they can verify their ideas and so on. For example, Bellsoft constantly merges patches from upstream, and I will have several examples a little bit later. Another thing is, if it's a big project like OpenJDK, then we can share security testing with other interested parties, like happens in OpenJDK vulnerability group. Speaking about OpenJDK vulnerability group, it's a way of all the bigger companies, including us, to share their information about security vulnerabilities, to fix Java, to fix OpenJDK before people know about vulnerabilities. And this is a beautiful thing. There are several sources of security reports. There are bug bounty programs. Larger companies like Oracle, Amazon, Red Hat have them. So white hat hackers do the security research, they find potential vulnerability, they report it to their company, and they're being financially compensated for their time and effort if it's being trashed as a valid security vulnerability. And after the vulnerability is fixed, their prior work is usually being published. It depends on terms and agreement between company and white hat hacker, but in general, it's totally possible, and it happened to at least some of Java patches. Also, private customers usually report issues to their vendors. If you're a client of Bellsoft, you can report issues to us. If you're a client of Amazon, they will be happy to hear a report from you. And if they decide that it's a security-related issue, they will act accordingly. And also, primarily at Oracle, but of course in other companies too, there is a huge internal testing of security. And when something is discovered, In any of these three ways, the security report is being created and sent to all the members of OpenJDK vulnerability group. It is a very small group. I would say it's dozens or so companies roundabout. All the information is closed. It means you can't find information on security vulnerabilities in open sources. And I think it's a good thing, actually, because, well, if anyone can find this information, then it can potentially utilize and use this vulnerability. When the report is in OpenJDK vulnerability group, Oracle creates almost empty CVE on NIST side, and it's almost empty because they don't want to disclose too much information on where the vulnerability is located and how to utilize it. Also, some of companies who are in OpenJDK vulnerability group develop patches, and then they send these patches to all the other members. And this is done in an encrypted way. It means that even if you somehow intercept the patch, you can't decipher it until you are a member of OpenJDK vulnerability group. All the communication is encrypted with participant PGP keys. Then all other members can apply this patch, excuse me, and backport it. And together with Oracle, they will coordinate disclosure and they will plan the release. And then all the companies who participate in it release Java at the decided time. Here's a small example of what happened. For example, OpenJDK CV 2024 21138. It's partial denial of service. On NIST side, it is marked as low risk. It's 3.7 out of 10, and it's very hard to execute. Details are not disclosed. It is considered to be unsafe, but they say that multiple network protocols are vulnerable to this thing. And what is interesting, all Java versions since at least Java 8 are vulnerable. We do not know exactly when this was reported, because if this information would be disclosed, then clients who use Java created before this date would be vulnerable, and potential black hats can know about it via social engineering or whatever. But we know that it happened not long before July 16th of 2024. And on July 16th, it was published and disclosed, and a couple of days before it, the Java release fixing this issue was done. But sometimes it's considerably harder than that. Sometimes it's an issue with an external component. For example, in 2024, there was an issue in GStreamer. GStreamer is a piece of software, as far as I know, mostly Linux, but I'm not sure, that it is software created to transcode files from one format to another and do a lot of different transformations on video and audio files and also pictures. So the crafted media file can override function pointer via malicious payload, and it could lead to arbitrary code execution, which is very bad. It means that if your service uses GStreamer inside and to convert formats or whatever, and malicious actor submits specially crafted video file or whatever it was to a service, they will be able to execute random code on your machine, which means nothing is safe. Like they can read your memory, they can delete data from your hard drive, whatever. It sounds bad. It sounds so bad that in this database, the score of this security vulnerability was 9.8 out of 10, which is only 0.2 short from the actual full-blown catastrophe. And how is it related to Java, you can ask? Well, it's simple. JavaFX natively supports multimedia, and it supports multimedia via GStreamer inside. And it means that potentially this vulnerability can affect JavaFX applications. So Look at the timeline. It is significantly more scary. The issue was reported and acknowledged in the end of September of 2024. I have the link here. If you will try to open this link, you will actually see a 404 error because outside users are not supposed to see reports about vulnerabilities because otherwise they can utilize them. And this issue was closed only 2 months later, hopefully. Hopefully, it was disclosed by a white hat hacker and no one could use it. But even at this point, Java was not fixed yet because JavaFX had to wait for the fix inside GStreamer, and then they had to apply their own fix on top. And then it took some time until the next release, which means that for Java, this issue was fixed only in the April release. From September to April, it's more than half a year, which sounds scary and which is scary. But the good thing is, at no point issues were disclosed. So when you use latest Java, you are secure. And the thing is, Bellsoft is probably one of few vendors who actually support JavaFX in all the Java versions. So we have to patch a lot of Java versions. We have to patch all of them from 8 up to 24. And we had to patch native image kit too, because it also comes with JavaFX support. And here is another example from Linux world, because the previous was only from Java. It was a vulnerability in Muscle, which is a standard libc implementation for Alpine Linux. An attacker could exploit a vulnerability in Muscle libc by providing a specially crafted input to the iconv conversion. Iconv is a small Linux utility that converts data from one character encoding to another. And it is like essential thing. Many programs use it, especially on a lower level. And in this particular scenario, this could lead to code corruption, which is a okay-ish, like your application crashed and what, to, in some cases, remote code execution, which is significantly worse, in my opinion, because again, as soon as someone can execute arbitrary code on your machine, they can do anything on the machine, or almost anything. And the beautiful thing about open source here is the patch was backported and ported to Alpaquita the very same day when it was published in the Muscle repository. And this is how patch lifecycle works in this case, and in general for critical components of Linux. We see the upstream fix, we backport or port it to our library, then we deploy it to the repository, which we support. Obviously, Linux is nothing without package repositories, so we publish it there. But it's not it, because you want to have your Linux secure at the time when you download it, when you do Docker pull, right? So we rebuilt all our Alpaquita images, which are essentially glibc Alpaquita and Muscle Alpaquita. And then, since we have a lot of downstream images, Java image on Alpaquita, Python image, native image kit image on top of Alpaquita, C++ image on top of Alpaquita, and so on, we rebuilt them all too on top of just rebuilt Alpaquita base. So we really heat up the universe just to make sure that all our users who use our images are secure. And I think it's a beautiful thing, actually. Like, yes, we have to do quite a bit of work, but at least every time when you pull your image, you know that there are no known vulnerabilities in images you just downloaded. What happened if it would be a closed source? Well, first of all, vulnerability can be just silently present, as it happened many times, and it could be silently exploited many times. Fixes could be delayed or hidden. There is no way for you, since you don't have source code, to verify if your operating system or your proprietary software is vulnerable or not. You don't even know if there is a vulnerability. Also, if it's an older piece of software, your vendor might require extended contract to fix it, because usually they don't care about older versions of their software. And also, usually these vendors do not have a vibrant community, and even if they have vibrant community, this community doesn't know about vulnerability, even if vendor knows. And it means community can't pressure on these companies. And if it can't pressure, if there is no community pressure on these companies, there is no urgency for these companies to fix anything. If no one knows, why would we fix it? It's like security by obscurity. In open source, yes, you can argue that the surface of attack is bigger because we all share risk of having this code open, but at least we can also share response. And if one party is not interested in patching this security vulnerability, another one will do it. So a small summary here. Vulnerabilities are obviously inevitable because, well, it's impossible to write code without bugs, sadly. But at least open source allows to detect faster just because more people looking at the code and they're doing their own security audits and so on. It allows faster fixes because we share responses to these issues. And there is better hardening because you can modify software in any way you want. Open source isn't just a code, it's a contract with you, with the community. And at this point, I would like to end my presentation, say thank you, and say, let's make software that's secure because it's open, not in spite of it. You can find me in Blue Sky, you can find me on our blog, and so on. Thank you so much.
Well, thank you, Pasha. That was cool. Now we know what it takes to keep a project safe and stable. And now, as I promised, it's time for our Q&A session. So I have all the questions that you asked, friends, and I'm going to pass them on to our speakers. I know that Margarita has to go in like maybe 10 or 15 minutes. So I wanted to ask the questions in turns, but let's ask all the questions for Margarita, if Pasha doesn't mind. And then we'll let her go, and then we'll stay with
Sure. Of course.
Great, thank you. Okay, so and here's the first question from Pasha, by the way. So, can you statically analyze prompts?
That's interesting. What do you mean by statically analyze? Like
No, I mean, you have like a system prompt in your software, probably almost hard-coded, or maybe somewhere in properties. Is there a way to understand if it is easy to inject prompt there or like some malicious prompt or not?
I think like you can. It's the matter of like building some intermediate representation, building to vector of words, and then like analyzing it. And I think like that's probably at some point that's what the current tools that provide some sanitizers validations and are doing. I would not probably call it statically analyzer, like just analyze the prompt, because it's not like
Okay, it's not the code, but in
yeah,
a way, it's the
it's
code
not that
now.
there is a way to analyze it dynamically. It's like yeah, but yes, I think like that's probably what we can do. What we should do is to analyze the prompt and understand. Yes, and that's a good question, because it's not just about the user input but also your system prompt. Yeah.
Thank you.
Okay, thank you. Okay, so the next question is from Bash. Which security scanners for Java can you recommend?
That's a funny question, interesting question. I looked at our that you posted about me on LinkedIn, and Sonar liked it. So I don't think I can answer anything else except that at Sonar we can find your like vulnerabilities, and it's like not just for code quality, but we do a lot of effort in security. We don't yet have any offering for prompt injections, but stay tuned. I don't know. I think there is a huge opportunity for us to work on this direction. And yeah, I cannot suggest you our competitors. So but if you check the website and for some reason you're not happy with Sonar, reach out to us and we'll figure it out.
Great, that's a good answer. Right. Another question from Priya. Are you integrating AI or machine learning for intrusion detection or anomaly monitoring in JavaRush? What has worked and what hasn't?
Yeah, unfortunately, we don't. But indeed, I think that's a great opportunity to use AI there. Actually, maybe not just AI. When I was in university, we had just data analysis, and that was about we did some type of research of detecting anomalies and detection of some. And this is exactly about it. But yeah, at Sonar, we are not doing it. And our product are not doing it because we're doing static analysis, not kind of dynamic analysis. But indeed, this could be a great opportunity for AI to shine here.
Hey, thank you. So the question from Frank, can we expect that AI will bring even more cybersecurity threats in the future?
More than today. Yeah, I think the way how the software is evolving, the security breaches are also evolving because every time if there is some shiny new technology, there is also another part of people who find a way how to break this shiny technology. So yes, it will, and the more mature AI becomes, the harder it will be to protect. And then even as we discussed during our conversation that prompt injection is very close to social engineering because that's behaves like we try to emulate the behavior of human brain. And yes, the more mature it becomes, the harder it will be to work with this and maybe to on the one hand to trick it, on the other hand to detect that it's tricked.
Okay. Thank you. The question is also from Priya. Are there tools that can assess how secure the prompts are before feeding them to AI?
I think at the moment that every API, every library that allows you to integrate with LLMs provides also the built-in methods, built-in best practices, how to validate your input. And I've seen over the internet that there are some tools here and there, but I don't think I can recommend anything because I don't think any huge player announced anything. Maybe so I'm not really. I don't think I am eligible to recommend anything. But yeah, there is lots of data on the web, and if you take LangChain or is, for example, I think there is Spring AI or Quarkus AI. They all have APIs to validate the prompts. It's hard to say how good they are. But it's of course they are aware of the problems of prompt injection and that prompts should be validated, so you can use built-in methods to use it.
Okay, thank you. And so there's a question from Mitya. So how hard or how long it is to extend existing Sonar checks with custom analysis? Let's say if I want to introduce some company-wide check, or that every call, for example, should include some specific header or special rules for Kafka consumers or producers.
I think that's widely depend on what exactly you use because you have SonarQube Cloud and SonarQube Server and which language you're using. Because if you're talking about Analyzer for Java provides an API for custom rules. So you can create your own plugins, then install it into your SonarQube version and use it. However, it doesn't work in SonarQube Cloud because in SonarQube Cloud, you're not allowed to install your plugins. So it will only work if you have on-prem installation. And depending on the language, some languages also provide APIs. Other languages provide some sort of a XPath way to create custom rules. And some others are just only thinking about it. But what I can definitely say that at Sonar we notice demand, and there is like inconsistency between the tools and the languages. So we are working on this. So stay tuned. Like, and at the moment, if you want it right now, there is also a way that you somehow create an analyzer on your own based on like how you want. It could be IST based, it could be regex based, and then you generate the report in a way that Sonar can understand. Because Sonar, it's both Sonar Cube server and Sonar Cube Cloud. We can understand third-party reports if you provide them in a proper like in the way how we expect it to do. And there is a documentation where you can understand how to generate such a report. So we'll be able to import your external issues. And for now, this is kind of workaround, but yes, we are aware of this demand, and stay tuned.
Okay, well, thank you so much, Marita. Those were all the questions from the audience. How can they connect with you on social networks if any more questions arise about Sonar Cube or AI threads? So
It
where can they find
depends.
you?
I think like it was really nice talking to you, but just to have a disclaimer, I am not a huge security expert, so I'm just like also only started working in the security domain. I mostly was in the code quality domain. So if you have more general questions about Sonar, about security at Sonar, our offerings and so on, it's better to actually go to our community forum, and there are even much. Like smarter and much more advanced people than I am, so they can answer you. And like if you want to just follow me on social networks, it's on LinkedIn. I think it's with my name, Margarita Nedzelska, and with I'm still on X, but I don't check it very often, and on Blue Sky as J Margarita N. Yeah.
Okay, well,
Thank you so much.
thank you. Thank you so much. That was a pleasure talking to
Thank
you.
you.
It's very
It was a
interesting.
pleasure for me too. Yeah,
Bye
bye bye.
bye. All right, Pasha. So, are you ready for your questions?
Let's try.
Okay.
Never ready. Never ready.
Nah, all right. So it's just go with the flow. So too many cooks spoil the broth, right? Harihara says that was about the open source projects that can accept
Uh,
contributions for.
Obviously, too many cooks spoil the broth if they do not communicate with each other. But otherwise, if you have ever seen how good restaurants work, there are a lot of cooks and they work in a nice orchestrated pattern. There is usually some important cook, let's call him first among equals, and he helps everyone to coordinate, and the broth is eventually beautiful.
Okay, thank you. The question from Masha: which tools are used for testing the stability and lack of performance regression in the builds?
JTrack, JMH, and whole self-written test suite in OpenGTK. And for Linux, it's much more complicated because Linux is actually a set of components, and each of components is being tested in its own unique way. They're usually being fuzzed by different instruments and so on.
Okay, thanks. Question from Ainura: is it better to use distroless images and have no CVEs in the first place?
It is better to have no CVs in the first place. It is not related with being distroless or not. You totally can have CVs in your distroless because distroless is a lie. Distroless is not a thing. They still have distro is just very minimal. It doesn't mean that it's not vulnerable at all. And at the same time, there is some trade-off you should make at some point. Do I want to be able to debug what happened with my application in runtime in production? There are a lot of people who like, for example, Wolfie Linux, and I'm kind of on board, but they also complain that when something crashes, they don't have a single tool to understand what went wrong. You can't easily reproduce it. You don't have your core dump. You can crash dump. Nothing. It just crashed. Good luck resolving it however you want. You have DNS issues, no way to debug them. You have HTTP issues, no way to debug them too. Nothing. You can't install curl in there and so on, which is an issue, for real maintenance because we write code once, but we run it in production, hopefully for a very long time, and things will happen, and you need a way to understand what happened. I mean, it's just a visual thinking to say that there are no bugs. I once had a piece of software which was in production for half a year, and we didn't have a single bug. But after this half a year, the bug was found, and it was actually a severe one, and we had to run around and fix it. And I'm so grateful that we didn't use distroless images back then, because I was able to at least debug it a little bit and have some insight in what's going on. So yes, no CVs, no, I don't care about distroless.
Okay, thanks. The question from Steven. Does the team take part in identifying CVs or just uses the information from OpenJDK and Linux CVE reports?
As far as I know, we didn't find any interesting CVs for quite some time, but a lot of our engineers who are participating in security audits and so on, they're very keen on this topic. It's just hard to find really interesting, easy to execute, and potentially dangerous CVE in Java. Too many folks are eyeballing it, including us, obviously.
Mm-hmm. Right. Thank you. And the last question from Mitya. How long does it take to run all tests before the builds are released?
I don't know, to be honest with you. I didn't ask. I didn't watch. I know that even for kind of simple product, for IntelliJ IDEA, to run all the tests takes 3 days of pure time. They're obviously massively paralleled, and thanks to that, you can have all your tests ready in like 4 hours, maybe even under 4 hours. But it is hard, and it takes a lot of machines to run them. I bet for OpenJDK, it's even longer than that. And I'm not even speaking about JCK and TCK, which we should stably pass to be able to call ourselves JDK, OpenJDK.
Mm-hmm. Yeah, that's a lot of work,
Yeah.
I guess. Well, that's about it, I guess, about the questions. So Pasha, Margaret, and Daniel, who might be watching the recording later, thank you so much for making this webinar happen. That was a pleasure, and that was super exciting. And thanks to everyone who joined us. It was fun. Thank you. The recording of the webinar will be available shortly. So if you want to watch it again or you missed some parts of it, you can just watch it later. If you have any questions to me, to Pasha, or to our other two speakers, you can reach out for us on LinkedIn, on X, or Blue Sky. We are everywhere. Well, I guess that's it. Thank you.
Abandon Twitter, go to Blue Sky. We don't
Yeah,
care about Twitter anymore.
yeah. Twitter is slowly dying, I think, in a way. Yeah.
Thank you,
But
everyone. Thank
a
you
lot
for
of
having
people
me.
actually
It was
come from
amazing
Twitter.
experience.
So yeah. All right. Thank you. Thank you so much. Until next time. Bye bye.
Bye-bye.